you all are aware what is all about like computer memory. We are having primary memory and secondary memory. In primary memory, we are having RAM and ROM, and in secondary memory, what we are having our hard disk and other things. So we today we will discuss main memory. Okay, so program must be brought from disk into memory and placed within a process for it to be run. So what is the need of memory? Without having the memory, you cannot load your program into the computer because where it has to be loaded, it has to be loaded into the memory only. And main memory and registers are the only storage that CPU can access directly. What are the source of storage that can access by the CPU? CPU is what? Central processing unit. Okay, so these are the two things that CPU can access directly. And to access the register, CPU has to take one CPU cycle or less because it is very close to CPU. And for accessing the main memory, it can take many cycles to access the data from the main memory. Now, cache sits between main memory and CPU registers. Cache memory, I guess you must have aware of what is a cache memory. It sits between the main memory and the CPU registers. Means it is faster than main memory but slower than CPU registers. Now, protection of memory required to ensure correct operation. As you know, in memory management, we have to do the protection also from which we have to protect our memory. Means there are multiple processes are running in the computer system, so that one process cannot access or do not try to access the memory space of any other process. If it is so, then there is a chaos in the system that you are accessing the variable or the constants or other things of the another processes if we are not properly doing the production of the memory. So what is the basic hardware that we used in main memory? Each process has a separate memory space in which the ability to determine the range of legal addresses that the process may access. Uh, so what is the meaning of the separate memory space? Means to execute one process in the computer, we have provided a separate memory space that you can use this part of memory block, and you have to put all those things in your this space only, just like you in your home, that you are having a study table that has been given to you particularly for your purpose, that all of your belongings of the study material will has to be placed on that study table only. This is your area that from which you can either put something or you can access something. Similarly, your brother or sister is having another study table and she or he is having her material or his material on that. Or you can think of a cupboard. Each and every family member have a separate cupboard in which they can put something and they can access something. And if what happen if you try to put something in your father's almirah, then you have to firstly look into your almirah that my content should be in must my almirah. And if you are accessing the memory space of your dad almirah, then suppose he wants to put something on his memory space, then there is something already is there which not belong to your dad, but it is you. So there is a chaos in that situation. So that is why we have separated each and every memory space, having a separate memory space given to the processes for the execution. And as you know that suppose there is a stack of cupboards, so there must be a legal address space. Means there must be a you must aware that this almirah is you only and it is started from here and it will finish it here. You have to put your belongings here only. Now we are having two registers to find out the legal address that you can access. First one is base register. What is the working of base register? The base register holds the smallest legal physical memory address. Means it is the starting point from where you can start placing your things into the memory. And then we have a limit register. What is the need of limit register? It will give you the maximum value. The limit register specify the size of the range. Means it will gives you the maximum value from which you can travel from value to the limit value. Let's visualize this into a form of diagram. Here you can see that we are having three processes: process 1, process 2, and process 3. And these processes are in the memory of operating system, main memory. We are having this base value at this point, that is 30040, something like that, and we have a limit 120900, means this process in between process 1 and 3, that is process 2, can have this area specifically belongs to this process only, in which this process can either put something or can access something. It cannot go beyond its limit, that is 120900, because after this limit there is another member in the family that is having its cupboard. So are you able to get this base register and limit register? Do you have any question? You can ask. See, as I'm not able to see the chat if when I am on this presentation, you can unmute yourself and ask your queries if you have any. Let me know. Do you have any query till now? Pretty simple things we have discussed. Basic hardware that we have used are base register and limit register. So please unmute yourself and give me the semaphore signal. Do you have any question? You can ask me, or I have to switch between uh, here and there to see the chat box. As I can see, there is no query. So are we good with this right now? Do you have any question? Please let me know. Yes or no? Come on. Are we good till now? This is so much silence, pin drop silence is there. You can unmute yourself. Come on. Are you there? Are you listening? Okay. So at least give me the signal so that I can feel that I am in a class, that I am in a class, not I am talking to myself. Sometimes I feel that I am like a talking Tom. Abhishek is saying unable to unmute. No, why this is so? Let me check. See, you can unmute yourself. There must be some. I have not logged the users, like viewers. I have not logged. You can unmute yourself. Okay. So only 22 students are there. Okay, so um, shall I proceed? Someone is writing something. Okay. See, the good thing is about this slate is we don't have that 40 minutes time limit. So we can have a liberty to discuss 5 to 10 minutes more, right? Okay, moving ahead. Now, how to protect this memory space? So we will discuss protection of memory space. The base and limit registers can be loaded only by the operating system. Now, what we have discussed in the basic hardware, that we have a base register and a limit register. Base register will give you initial value, that is your starting point in the memory from where you can start, and your limit register is what your maximum reach from that you can proceed. So in between base and limit register, you have to do whatever you want to do, right? So let's have in this diagram, like a CPU is having some like physical address or some like one address is you can talk about right now, that CPU is providing one address. It will check with the base register if it is greater than equal to. If it is no, then we there is an error, trap to operating system monitor addressing the monitor. And if this address is greater than or equal to base address, yes, we can go into our cupboard, and then we will check base plus limit, that is what is your threshold value. If are we not exceeding that limit, if it is less than, then yes, we can put that into the memory. Otherwise, we again trap to operating system memory addressing error. So it's pretty simple concept, that firstly you have to put a address into your base register. Let me draw something so that
You are now
you
unmuted.
stand. Uh, we are having base register, base, we are having a base register, right? Suppose base register is there, and its value is, suppose it is started from memory in 1000, right? And then we are having a limit register. We are having a limit register. It will hold the value. Suppose it is having the maximum value that you can reach is 5000 in the memory, right? Now, if like a CPU has fetching, like a process wants to fetch a memory space, we are having a process. Suppose we are having a process. We are having a process. Suppose we are having a process, and it wants to access the memory space of like what? It wants to access the memory space at 3000. So let me know, this process can access this 3000 memory space? Yes or no? Come on, tell me. Unmute yourself. Process wants to access the memory space at this 3000, and base is 1000, limit is 5000. Can it do so? Yes or no? Come on.
Yes,
Yes,
sir.
sir.
Exactly. It can access, right? And suppose if process wants to access something like this. Suppose process wants to access a memory space 6000. Can it do so? Is it possible
No,
for this process? No, no?
No, sir.
no, it will not be possible.
Not possible, right? And suppose we are having something like this. Suppose it wants to access this memory space. Can it do so?
No, sir.
No,
No, exactly.
No, sir.
Because your starting point is 1000 and your limit point is 5000. You must be in between that, right? You must be in between this range, 1000 to 5000. You must be lie in this only. If you are beyond that limit, then there will be an issue, there will be an error. So this is what this presentation is telling you, that firstly you have to check with base greater than equal, then you can go, otherwise there is an error. And then you have to check with the limit. If it is within your limit, then yes, you are good to go to place that thing or access that thing into the memory. Otherwise you have to trap into the error. So are we good with this diagram? In examination, if this thing is come, you have to make this diagram in full page, right? Okay, so let's move on. Now, how to use the address binding? What are the different type of address binding we are having? Let's discuss. We can bind the address at the compile time. As we do, you remember that we are having array. Array, we have to give the maximum size at the starting point only, right? Do you remember at array is static memory allocation, and those things which are static memory allocation, we have to give the required memory space at the starting point only. Suppose you want to an array of 10 elements, then you have to give 10 maximum value at the starting point only, and this is called compile time binding. Means at compile time you have to tell your system that you need this much of space required. Just like in your house, if you are having your house party, suppose it is your birthday, and you want to invite your friends, then firstly you have to tell your mother that how many guests are coming, so that she can manage accordingly, right? Suppose your 10 friends are coming, then you have to told your mother will ask you that how many persons are coming, so that she can do like uh, like dinner or lunch, something that you can serve to your friends. Because if mother is not knowing how many persons are coming, then there must be a chaos once all the guests are coming, right? So if you are telling your mother that before starting or execution of that party. This is what compilation means. You are compiling all the if and buts, all the requirements that must be there in the runtime, right? So at compile time, you give all the information to the system that I need this much of a memory space. And then we are having a load time address binding, and we are having a execution time address binding also. Execution time is your run time. Load time is excuse me. Some compilers what do that they don't do not compile time binding. They do the load time compiling. Means do I guess you have remember that we are having a loader. Loader is used to load the program from the memory to the main your hard disk from the memory for the execution. And so at that time it will bind the address. So let's have a diagram on this. What is the activity on this? So firstly, you are having a source program, and then in compile time, compiler or the assembler will do the binding and create an object module, and other object modules just like your predefined header files that are there. So and their object code must be embedded on your own file that will be linked at the load time in the linkage through the linkage editor in the load module. And once you are done with the load module, we are that will be fetched into the loader, and system library will be there. And after that, in execution time, dynamically loaded system library will be placed into the in memory binary memory image. That is your final file that will be executed, and this is called dynamic linking. So pretty simple flow. You can see here you are starting here like source program, then compiler or assembler will be there that will convert it into object module, and then we are having a linkage module is there at the load time. In through to loader, we are having a load module that will load all the objects, user object and the system objects modules, and then in the loader, system library will be placed, and after that your binary files, binary image of the program will be created for the execution in the runtime. So this is your address binding techniques like compile time, load time, and execution time. Now, what is the difference between logical address space and physical address space? As you know, physical means your real address. And what is your logical address? Means, can anyone guess what may be the difference between logical and physical address? Can you have some real world example on that? Logical versus physical address. Do you have your logical address or your physical address? What is your physical address and your logical address? Can anyone tell me? Just think about it. Come on. Physical address, you are very clear that you are having your house address, right? You are living in Allahabad, you are living in Kanpur, you are having particular locality, like you are living in Rajajipuram area, and you are having your address is something 530 oblique 12 something like that, right? Do you remember? Do you remember your address? Everyone, do you know your house address? Do you know your house address? Come on. So your house address is your physical address. Your house address is your physical address. Now, what is logical address of you? Can you? What is a logical address? Can you think? Logical address and physical address. Any real world scenario you can think of? Then we will discuss in context of. Sometimes you don't give your friends or other members your exact physical address. You give them your logical address from where you can reachable, but you don't disclose your actual house address to someone. How you uh, come on, tell me if I can, if I'm to say everything, then you will how you will think. Come on, logical address. Tell me logical address. Who will tell any real world example of logical address? Come on. Physical address, you are clear, no? Physical address is your house address, right? And what is your logical address? Gmail. Yes. Yes. You are thinking right direction. Through your logical address, you are reachable also, but this is not your actual address. Very good, Adarsh. Gmail is your logical address, right? Not your physical address, but physical address you are reachable. So do you get the concept? Physical address is you are exactly there into the memory, and logical address is we are using. So if, for the sake of secure, we don't want to disclose our actual physical address, right? You know that you don't know my physical address where I am right now, but yes, through logical address we are connected to each other, right? Through this like Slate platform, you are uh, accessing a class link. This is our logical address where we all are on the same page, right? If we are in the our class, that is our physical address. Someone comes to ask where BCS secondary class of operating system is going on, they can say, okay, in FLT2, this class is going on, and they can come and see that we and the teacher is there in the classroom, right? But in virtual world, we are having a logical address that is where BCS secondary operating system class is going on. Then what is the logical address? This is the form we are having this online class, and the timing is 9:40, right? And if the authorities have the admin login, they can see, yes, in this particular address, this class is going on. So do you get the concept? Do you get the concept? What is the difference between logical address and physical address? Let me know. Pretty simple. Simple that physical address is your exact address in the universe where you are, right? Here anyone can come and buy that, yeah, this is your house, you are living here, right? This is your physical address. And logical address that you give for the sake of security, that no one can come at any point of at your house and do whatever, like meet if you don't want to meet, something like that. What is the liberty in your logical like your WhatsApp number or your Gmail that someone can post to you, but it is up to that if you want to reply or not, right? It is up to your convenience. When you are free, you can reply. And so these are the example of logical address, right? One thing I want to say that in class test, I have asked three real world examples that are not related to computer science for the deadlock situation. And I'm very sad that everyone is having the same answers, and most of the persons are writing those answers that we have discussed in us. See, if you are writing the same answer, everyone is writing the same answer, how you are unique, right? I told you that your answer must be different from your classmates. I have given you example of stack. Do you remember that Bengals example? Do you remember? I have given you one example of stack. Yes, your Bengals example. Do you remember? Yes or no? That example you will not find anywhere in the book, right? And if you write that answer into the answer sheet when others are writing about the stack of books, stack of plates, then your answer must be visible, a unique answer. But as I explain that answer to the whole class, that everyone is writing that this is an example of this stack, right? You must be think differently. Can you just for the sake of understanding of the topic, can you tell me another example of a stack that must be not in this, or I have not told you? Come on, tell me any other example of a stack. Come on, tell me. Please respond. I cannot be just like talking blah 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 blah, and my students are just sitting at the comfort of their house. sipping that tea, eating their omelette. Yeah, this is not like that. Come on, use your brain. Tell me. Come on, who will tell? Come on, students. You are in BCA second year. Come on, have faith on you. You can think something. Come on, tell me. I will not let you leave the class until you give me the answer. Come on, I will not proceed. I get one answer. A unique answer from your side that must not be in the books, that must not be discussed in the class. Come on, tell me. Tell me unique example of this stack. Come on, who will tell? I'm giving you an opportunity to come into the limelight, right? Come on. Am I visible? Am I audible to you? Why is there pin drop silence? No one is asking something or writing something. Are you there? Hello, the students. Are you there? Come on. This is not done. Come on. No response. Very good class. Take this as an homework. Come up with some good example of your stack. Must not be in the books. And think about some more real world situation about the deadlock. Like the answer, the way everyone has written. In the only 35 students given the test, and most of the answer same. Okay, so see why I'm saying this to you because this is your life. You wants to use your brain as much as possible. It is beneficial for you only. If you are just going for easy thing, then your mind will never be developed, right? Because you think that if I just ignore the problem and everything will be fine, then this will not work for your brain. Brain is your machine. If you are not to use particular machine, it will just there will be rusting it, right? If suppose you are having your sport bike, uh, like flat bike is having, but if you are not using that bike, right, then after 5 years and 6 years rust will be there, and it will be and you're like if someone is having a splendor, and a splendor if you are oiling in 5 years on daily basis, then it will be good than your that bike, sports bike, right? What I'm telling you, it is the thing is the practice you are having of your brain, the way you train your brain, it is up to you. If you are using your brain continuously, it will develop more because it understands. My masters need a lot of stuff to understand, a lot of stuff to think about. I must be cope the expectation of my master, right? So your brain will extend the horizon of your understanding. If you are making things like a small baby, then your mind will not think that master will is not using me in a full capacity, then why should I do more effort? Master is doing very small things, then why I think about more, right? So it is up to you. If you are using your brain a lot, it will give you a much better solution for your problems. So it is up to you. If you want to make your brain develop, it is up to you. And then we say that I am not like other. If someone is scoring more marks, why you are comparing me to that person? Yes, there is no point of comparison, but compare it to yourself, that yesterday where you were and where you are right now. What is the progress from the yesterday you are having in your life? What are the things that you yesterday? What are the things you are knowing right now? So what is the progress in your life? If there is no progress, if you're not learning anything from your yesterday to the today, then what you are doing? You are eating and sleeping and watching YouTube and surfing the internet. What new things you have learned? Just ask yourself when you are going to sleep that what new thing you heard, what new in a single word you have learned. or as experience that you haven't, or real world scenario that you can relate with your virtual world, anything, any progress are still like a small progress in your life, it can sum up make you proceed in your life. So think in that direction and help you out. So I'm moving ahead. It is already 9:37. Okay. So what logical versus physical address space? Very good answer we have given on the logical address of a person, like your contact number, phone number, and your Gmail. These may be a think of your logical addresses, and physical address is your house address, right? So let's see. What is a logical address? An address generated by the CPU. Now, logical address is generated by the CPU. In Viva, they ask what is how logical address you will get. Then your answer must be sir, logical address will be generated by the CPU only. And these, as you know, logical means virtual address, pretty common thing. And what is physical address? An address seen by the memory unit means your actual memory unit address into the memory, so loaded into the memory address registers of the memory. So this is physical address, and logical address is an address generated by the CPU. Now, what is dynamic relocation? Using a relocation register means how you convert logical address into your physical address and how you convert your physical address into your logical address. The runtime mapping from virtual to physical address is done by a hardware device called a memory management unit. This is a very uh, good question asked in many times in the examination, that to explain the memory management unit and what is the working of memory management unit. So what is the working and purpose of using the memory management unit? The runtime mapping from virtual to physical address space means you are having a logical address space, then you have to convert it into your physical address space. And tell me, are you have studied computer network in last year? Tell me, have you studied computer network? Uh, do you have idea of IP address and MAC address? Do you have IP address and MAC address? Do you have idea? IP address and MAC address. Come on, tell me. Anyone have idea? IP address and MAC address. Have you studied computer network? Yes or no? Come on, tell me. Do you have idea? You have no idea about IP address and MAC address. Okay, take this as an example. Sorry, take this as a homework. Okay, so this is a new thing you will learn today, and tomorrow you can think that yeah, yesterday I find out the answer of this. What is an IP address and the MAC address? Okay, to for the helping, I'm just giving you tip that IP address is your logical address. Uh, Pooja is saying IP address permanent. Yes, it is a logical address, and your MAC address is your physical address, and you have to put the full form of MAC also and how it works. What is the difference between IP address and the MAC address? Take this as a homework. In next class, we will discuss on that. Okay. Uh, okay. Find the difference IP address and the MAC address. For this, you have to do the little study at the computer network side. Okay. So let's finish this off today's class. The runtime mapping from virtual to physical address is done by the hardware device called the memory management unit. The user program never see the real physical address, means the user, we don't want to disclose our real physical address, we give them only virtual address. As you can see here, CPU is generating a logical address that is 346. Now there is a relocation register that will let you reach to the physical address space. It will do the processing by using your logical address and doing some processing in the memory management unit, and then it will generate a physical address, and it will reach you to the memory that you want to either put something or access something, right? So we don't disclose the actual physical address to the normal users for the sake of security. We are using a logical address only, and then we convert into your physical address with the help of a relocation register. Okay, so we are done with today's class.